Hi, everyone. Thank you so much for joining us today for our event on GKE cluster upgrades. My name is Lauren, and I'm the content manager for the Google Cloud community. Joining us today is Aaron and Jimit, who will be taking us through the content and answering your questions today. Questions are encouraged, so please feel free to add those into the YouTube chat box, and we'll be sure to get to them in the chat or at the end of the presentation. And for any questions that we don't get to, we'll be sure to follow up with you in a recap blog post in the Google Cloud community. And you can find a link to that in the YouTube description. Okay, with that, I will hand it over to the team to get us started.
Thank you, Lauren. Um, Good morning, good afternoon, good evening, wherever you are. Everyone, thanks for joining. Thank you for your time. I think we should jump right into it. Okay, so this is the agenda, for today. And before we dive into the agenda, let's talk about why we are talking about the GKE upgrades and why the Kubernetes or GKE upgrade has become such a cumbersome task in recent years or so. So, just a quick background. When Google wrote the board paper back in 2013, the Kubernetes was not designed for the stateful workload. So that was the first um, intention of creating the board paper or the Kubernetes. But as the time progressed and we started incorporating more changes, uh, that those changes started including more features, add-ons, and that ultimately made the process a bit complicated, so to speak. So why this is complicated again? So you have your own deployment CI/CD pipeline, and then you have your own cadences implementing business logic. And on top of that, if you see those notifications from GKE, say your API has deprecated, right? And your GKE cluster is now on end of life version. So these notifications, and then once you update APIs, then you have another problem, the minor version. Once you update the minor version, then we have another minor version which is now default. So the cycle keeps on going in circle, and we end up managing the cluster more often than not. So GK in general, we are working internally to streamline this process in coming months or so. But for now, we have a few tools at our disposal which we can use to make sure that we do not see any disruption, and we have sort of kind of smooth transition from one version to another. Okay, with that note, we'll cover in next 40 minutes or 45 minutes release channel, no release. You must have, if you are using GK, you must have heard about it. We'll cover basic concepts, right? And then how can we reduce those disruptions, as I mentioned, and also what are those controls that customer has on their end to avoid those upgrades, and then followed by the Q&A. So, okay, let's dive right into it. What's in a release and how do we roll out? So, as someone said, maybe one of these guys said, "Thou shall update all the apps all the time." Um, I think my bet is on Socrates, but yeah. So if there is an app, we have to keep updating, every now and then, because sometimes technologies gets obsolete, or as I mentioned, API sometimes gets obsolete. So, and Kubernetes, if you think about it, it's also an app. It's a container or orchestration service, but it's also an app, right? So we have to keep updating Kubernetes. And coming to the Kubernetes part, I'll be referring a lot of minor version, patch version. So just to make sure that we have our base clear, um, that's how we read. 1.24.5, just an example, dot GKE10. So minor version 1.24, the 24 is our minor version, and then we have Kubernetes patch. These patches can be the security patch, and then the GKE point 10, it's the GKE specific part, so the cloud vendor specific part that we made some adjustment to the open source Kubernetes. Okay, shared responsibility model has been around, and it's the same case with the GKE. So we have earlier it was like every 3 months we used to release, the open source community used to release one GKE version every 3 months, so 4 version in a year. But last year, since I think beginning last year, the cadence has now reduced to 3. So every 4 months we have a new minor version, and then we release the feature of, couple of patches. If there are any security vulnerabilities, we patch our GKE. So this is the cadence, like 4 months, one version, 3 version in a year, and then patches every month. Um, and then we have two basic parts in GKE. One is control plane, one is node pool. So I'll be, in short, I'll be using CP and NP. So GKE always maintains your control plane regardless if your cluster is in release channel or not. So we'll talk about release channel in a bit. But yeah, if since GKE is a managed service, managed Kubernetes orchestration service, control plane is highly available, and we make sure that you have couple of replicas running across the multiple zones. So, and that is the case with the regional cluster, and I'll talk about regional versus zonal cluster in coming slides. So bottom line is control plane is always maintained by the Kubernetes by the GKE. Node pools, however, you have the ability, you have the option to auto upgrade, or you can upgrade by yourself. I mean, you can disable auto upgrade, which is not recommended, but given your use case, you can go ahead and disable the node auto upgrade. So this is how it starts. From open source community, we release a feature, and then in a few weeks we make that version, minor version, available in our rapid channel. And as the as you can understand, the rapid channel is not very mature enough with all the features. So we recommend our customers to use it as like early adopters, check all the features whether it is compatible with your current workload, or do you have to do any sort of changes before you make it to your staging or production area. So in 2 to 3 months, after 2 to 3 months, the soaking time, we check internally that we are not breaking anything within the clusters. Then we graduate it to the regular, and most of the early maturity uses regular, and after 2 to 3 months is staying in regular, we move that regular version to stable, and this is the most, as the name suggests, it's the most stable version. So starting from open source community version to stable, it takes about close to 6 months or so for a version to become available in stable channel. So let's, before we go ahead and talk about no channel, and let's spend some more time here in release channel. So maintaining, as I mentioned, maintaining GKE itself is a bit cumbersome, or Kubernetes in that sense. So GKE has created these channels to offload some of that work, some of that upgrade work from the customers. And once you enroll your clusters in one of these channels, GKE takes care of the maintaining or upgrade part on your behalf. And I understand that some of your use cases may not fit into these channels, and you do not want to enroll with it, and that is understandable. But we highly recommend that you enroll your clusters in release channel. But if not, then we have a static channel, which is like um, GKE will not maintain or upgrade your clusters except the control plane part. And there is a way to stop the upgrade for the control plane part as well, and that is called maintenance exclusion, that I'll talk in coming slides. So if you have gone through the Google Docs, you must have seen this table before. We have Kubernetes version when it was released in open source, rapid, regular, stable, and of life, right? So let's take an example of the upcoming end of life, which is 1.23. So right now it's in the stable state, release channel, and auto upgrade has already been performed. So when does auto upgrade happens? So when a version becomes default in any release channel, Kubernetes, if your cluster is enrolled in any of these channels, then Kubernetes will start upgrading those clusters within 10 days. So let's say if your cluster is in regular channel most of the time, right? And just taking this example 1.23, on 20th October 2022, it must have you must have received a notification saying that we will upgrade your cluster to to 1.23. So GKE does not upgrade your cluster when a version becomes available. It does upgrade when a version becomes default. So that's the bottom line. And if you are on static clusters, then and if you have not upgraded from the end of life, and if you are approaching end of life, and if you have not upgraded, then we will force upgrade your cluster, even in the case of static ones, um, to avoid any sort of um, version incompatibility. Version incompatibility I will talk in coming slides as well. But let's think of it this way: a control plane version and the node version can only be like two minor version lower than control plane one. So if you have your node version on 1.21, um, your Kubernetes version is 1.23, or lesser than that. So if we are approaching end of life, 31st of July is end of life of 1.23, and let's say if your cluster is not upgraded by this time, we will send out a notification first saying these many of your clusters are still on 1.23, and we will start force upgrading. But you have a way to stop that upgrade by using maintenance exclusion that we'll discuss later. Okay, it's just a CLI command, how you see any GKE version availability in any of the channels or static version. So this again talks about the release cycle. So GKE has like weekly release, but it does not mean that we update your cluster weekly. So and rollout takes 5 days, and it could delay because of Black Friday, Cyber Monday days, pause and rollbacks. As so all these pointers that we have provided here, it's just to make sure that you understand the cadence of release cycle, and you understand as and when GKE upgrades your cluster. So it's whatever we have discussed: new SS minor version release, rapid channel after 30 or 45 days. So take a look on your own time. Control plane upgrades. GKE always upgrades the control plane first, because to maintain the version compatibility, um, a control plane version, as I mentioned, and the node pool version cannot be lower than the two versions. So control plane first, and then if your cluster is on release channel, we try to keep these two versions at the same level. Let's say if we upgrade your cluster to 1.25, GKE will try to upgrade your node pool at 1.25. Yeah, and then about the frequency, um, these are the patches. We do not upgrade your clusters not more than once within 24 hours period, and one minor upgrade a month. So these are again the limitation when we do not upgrade your clusters. And these are the node pool frequency. First, control plane is upgraded, followed by node pool upgrades. Um, so, okay, now you have idea of the frequency, and these couple of these things we will discuss in detail in coming slides. But for now, I think we have pretty much uh, a clear picture, when and how GKE upgrades your node pool and when it updates your GKE cluster control plane. Why we keep on updating or upgrading the node pool? It's because there are so many features. The backlog is huge, and the open source community keep on adding new features, and that in turn, we have a new version every 4 months. And so the point is, we have a lot of innovation going on, and also the compliance, and to avoid any security vulnerabilities. Risk reduction and testing. So how can we reduce? So we cannot just stop upgrading our clusters, but there are like a couple of best practices that we can follow. So I'm sure most of you must have this setup, like development, testing, staging, and then production. So these are the recommendation. If you have development environment, keep it similar to the production one. Although sometimes you are not able to replicate the entire production one, because let's say you cannot replicate the same traffic inflow, right? So, but try to see the trend, the past trends that you have seen. I mean, at which sometimes, if you are let's say if you are an online retailer, you may have seen the spike in traffic during the holiday season, right? So based on the traffic, try to increase the capacity, or try to increase the size of the VM, that whatever you are using. So separate your environment into couple of testing environment and then staging environment. When everything is good to go, it should be similar to the production one. And then we have production, where everything is in stable or regular channel. These are few notification. We can share the link after this call, how to do the setup, so that as and when any new version is available, you can get an update on your Slack channel that GKE has a new version availability. So this is how the workflow looks like. So when any new version is available in any channel, you get the upgrade event notification. You should start upgrading your testing and staging clusters. And then um, you know, after the version becomes default, try to upgrade it into the staging area first. And as you know, as soon as a version becomes default, GKE start upgrading your clusters if it's enrolled in a release channel. So this is about the workflow, how the upgrade works. We can move on to the type of controls that we had at our disposal to prevent any sort of disruption as and when GKE start upgrading your clusters, or you yourself start upgrading your clusters. So maintenance window and maintenance exclusion, we'll talk in detail what these two features are and how we can use to align these features and to align our GKE cluster upgrade, um, whatever time that that makes sense to us, right? So maintenance window, you decide when do you want to upgrade, or sorry, do any kind of maintenance on your clusters. And these could be like, as you can see, it's off peak hours. Most of the time, let's say if you want to update your cluster during between 12 a.m. midnight to 4 a.m. So we have to provide like 4 hours of window. When we have a demo, I'll show you. And then let's say if you have on call on during the night or any time of the day, as and when your traffic is really low, then you can schedule the maintenance window. And maintenance window, since it's only maintenance per cluster, so it's only allowed one maintenance window per cluster. And the time zone, the reason why I mentioned the time zone, it's because it's really important. Sometimes I've seen the issues where customer has scheduled a time and that was in their local time zone, but actually the GKE read it in a UTC. So there was a misunderstanding of how the timing works when you are upgrading your maintenance window. So when it's G Cloud or API, it's in UTC, and if you are using console, it's whatever the local time zone you are in. And if you are viewing that maintenance window, it's local time zone again, as you are looking at on your console. And then CLI, um, if you are doing if you are looking via G Cloud CLI, it's on UTC. So make sure that you understand the time zone, and double check, because these maintenance windows could be disruptive. Maintenance exclusion. So this is one of the important feature that you can use if you do not want to upgrade your cluster at all. If you are not ready, then you are not ready. But there are few limitations as well, right? So maintenance exclusion allows customer to define what GKE should upgrade, how and when. Um, what I mean by that is, so let's take a deeper look here. So so we have like three types of exclusions. First is no upgrade, which is the default one. Um, it means do not perform any kind of upgrade, like do not touch my control plane, do not touch my node pools. But that is only valid for 30 days, right? We cannot just keep a cluster hanging for for an indefinite time period, right? We have since it's managed service, so we have to make sure that underlying hardware are properly upgraded and on time, and also we are not seeing any sort of vulnerabilities in those in those versions. And then we have no minor upgrades. So as the name suggests, it means we do not want to upgrade from, let's say, 1.24 to 1.25, but we are allowing GKE to upgrade the patches. So in next slide, we have a table of what all things that we include as part of no upgrade and no minor upgrade. But as you can see, it's first of all, it's part of release channel. So if your cluster is in static channel or no channel, you do not have this option at all. um, Maintain the current version, if to avoid any API changes. And then it's only valid for 180 days or version end of life, whichever comes first. So I have a cluster which is running in on 1.23. um, as you saw in the previous slide, the end of life is 31st July. So I cannot extend the maintenance exclusion beyond 31st July. And then we ask GKE to not upgrade the minor version, which is do not upgrade 1.24 to 1.25, and then do not upgrade nodes at all. So this one again is part of release channel. And if you want to avoid any eviction and rescheduling of your workload, you can choose this option. And then again, it's valid for 180 days or version end of life, whichever comes first. It would make more sense once we have the demo, but for now, let's move on. So this is the table. So let's say if you choose no upgrades, right? Um, Let's look at here. It's control plane, node pools, minor upgrade. Minor upgrade means 1.24 to 1.25. Let's keep on using the same example. And then patch, no upgrades means nothing. So you see the entire row says nothing is going to be upgraded when you have this scope enabled. And it's enabled for 30 days, as you know, and no minor upgrades. So when you have no minor upgrades, nothing would be upgraded as far as its minor version, but patches, yes, if to address any security related issues. And then maintenance during the, since we are upgrading patches, there may be a disruption due to this maintenance exclusion. So that's the reason we have mentioned yes. um, and then for the node pools, no minor upgrade, right? And then patch upgrade, the same goes for node pool as well. For this part, we do update patches, and that in turn, may lead to disruption for a few seconds or minutes. um, since it's no minor, so it follows the same no minor one for the control plane, right? But for the node pools, we also asked GKE do not update our nodes at all. Then it means the GKE would not upgrade your node pools at all. So I hope this makes sense. Whichever your use case is, let's say if you have couple of product teams and you are the platform engineering team and your product team is not ready to upgrade your clusters, we can use no upgrades. But since it has limitations, so we have to be mindful about the timing as well. So features and limitation, one cluster can have multiple exclusion. So you can have like no upgrade, minor, all three at the same time. And if one expires, GKE will honor the next one. And since no upgrades means do not upgrade anything, although we have this control, we have provided this control to the customers. It comes with 30 days window, and also after every 30 days you have to give us 48 hours of maintenance, because in last 30 days you did not upgrade anything. So there might be pending upgrades, pending patches, pending versions that we may need to roll out. And so for that we need like at least 48 hours of maintenance window. You can have maximum of 20 maintenance exclusions in total. So like whichever combination, so we cannot have more than 3 no upgrades. So let's say you have like another 8 no minor upgrades and another 8 or 7 no minor or node upgrades. So in short, 20 maintenance exclusions in total. So that was about maintenance exclusion. So let me try to show you how we can use it in our own clusters. So I hope you see my Google Cloud Console. Sorry about that. Let me. Okay. So oops. So I have these three clusters. One is on 121, another one is on static 125, and the cluster test A is on 124. Um, and I see these notifications that I'll discuss later, because these ones also really very important. So let's try to put let's take the example of static one, right? So you know that static only allows, in theory, the maintenance exclusion of no upgrades. So this is where we have to come: maintenance window, maintenance exclusion. Right now by default I have set up like anytime upgraded, so which is not the right setting. So if you come and enable maintenance window, let's say you want to upgrade like on a weekly basis, start time 12, length 24. No, we do not want to give 24 hours. We do not want any sort of disruption but the minimum you can do is 4 hours, right? So starting from 12 a.m., 4 hours length, and you can choose on which day or days you want your cluster to be, you know, upgraded for, patches or stuff like that. So I do not want, the only day I want to upgrade my maintenance, do any kind of maintenance on my clusters, let's say Saturday and Sunday 12 a.m., and that would last about 4 hours. So this is how I would, use the maintenance window. So as soon as you save this, hmm, something is not right. Okay, but yeah, I can assure you it does save. So you also have custom editor, weekly editor, right? So let me see. Let me try again. Okay, coming here, enable maintenance, save changes. So I was able to save it now. And then let's go ahead and do the same thing. 4 hours, Saturday, Sunday. The demo word is not happy. Anyway, so yeah, that's how you do the maintenance, right? Now let's talk about the maintenance exclusion. So you remember my cluster is a static one, static on 1.25. So let's add the maintenance exclusion. So you can see we have like, we are supposed to have three options, right? But we only have one because my cluster is not enrolled in release channel. So I only get to have no upgrades. And no upgrades can only last for 30 days, as you know. So starting today, May 18th, let's say May 19th, let's do another to June 19th. So you see, I'm getting an error, exclusion length must not exceed 30 days. So yeah, we cannot schedule anything. We cannot extend the date beyond 30 days. We can, but we have to provide 2 days of or 48 hours of maintenance window first before we can upgrade, or before we can set up another no upgrade. So let me try this. 18 days, 18 days within 30 days. So let's say if I want to start from 18th June, I'm ending my first exclusion. And if I try the next exclusion on 18th June, it's giving from 18th June to 18th July. Oh, no, it's not updating. So yeah, that's how you have to do the setting, and you have to fine tune these settings based on your use case. Coming back to end of life, we talked about that end of life one. We cannot extend the maintenance exclusion beyond that. So let's try. So I do not have maintenance window, it doesn't matter, we already seen it. So let's say now see, I have two more options here. um, no minor, no minor or node upgrades. So let's say no minor, and 180 days, that 124 is going out of end of life. Let me see real quick, what is the date? So 124 is going out of life on 31st October this year. So let's try to set up the exclusion beyond 31st October. Let's see how the system behaves. Okay, starting 19th, and then let's go all the way to 1st November. So yeah, we got an error saying end time needs to be before minor version end of life, which is 31st October. Um, so that's how you have to do the fine tuning of the maintenance exclusions based on your use case. So let's go back. So just a quick time check. We have like close to 20 minutes. Let's talk about the disruption during an upgrade and how we can, um, we can change our manifest file to make sure that we have enough time while we are upgrading our GKE cluster. So these are the type of workload: stateful, full, or stateful, or stateless, whatever you want to call it, batch and others. So stateful simply, one example that's the common one. You're watching Netflix, and if you want to watch from where you left off, you would like Netflix to store your session, right? So that is stateful application. And stateless, maybe you are doing a Google search, and once you shut down your laptop, you have to start the search from the beginning. So it means Google did not store any session for you. And then batches, you already know. So these type of workloads which may be disruption intolerant, and these are just a few best practices around your stateful workload. So if you want to deploy a stateful MySQL cluster, you can follow these guidelines, which are now published on Google Cloud public docs. And we will keep on updating our docs for any new use case which is in line with a stateful workload. So let's talk about PDBs, or pod disruption budget. So this is the, I think, one of the most crucial feature of that we should enable while we are upgrading our clusters. So what pod disruption budget does, it makes sure, based on the settings that you provide, that these many pods are always available while your node is transitioning away from one version to another version. So let's take an example. So let's say if you have a replica which has 3 pods, right? And you do not want your application to go down more than 2 pods when your node is upgrading. So the setting that you would like to do is minimum available 2. So GK will always respect your PDBs, and we will make sure that you always have 2 pods available at all times, given the settings that you have provided. And min available, max available in this case means the same thing. So if you have 3 replica, either you can set it up like minimum available 2 or maximum unavailable 1. It means, again, interchangeably we can use either of these settings. So make sure that you set the PDB according to your use case. Sometimes you may need like couple of hours to for your database to copy from one place to another before you upgrade your clusters. So by default, the GKE will respect your PDBs up to 1 hour. So that is the limit, but during the GKE upgrades. But if you would like to increase that limit, so in that case, you have to use a different upgrade strategy, which is blue-green, that we'll discuss later. So the bottom line is PDB make sure that you have your minimum available or maximum unavailable pods running at all times. And then we have another feature, pod anti-affinity and affinity. Take a look. I don't want to go in detail into these topics, these concepts. As the name suggests, we if you want to make sure that your pods are assigned to a specific node, GKE respects that as well. And just want to take a quick look of, depending upon your workload or the type of workload that you are running, there are some suggestions to the PDBs, that how should you configure it, right? So let's say if you are stateless, the most convenient workload which we can upgrade is the stateless one, because as the name says, we do not have to maintain any sort of a state, any sort of session for that matter. So this is the simpler one. You don't have to reduce the serving capacity by more than 10%. Then you can use minimum available 90%. For single instance stateful application, the recommendation is do not use PDB, or tolerate few downtime. If it's not possible for you, then set the PDB to maximum unavailable 0. So again, it may have some more complications, because when you say maximum unavailable 0, it means you are telling GKE keep everything available. Then what is the point of GKE cluster upgrade, right? So in that case, you have to make sure that you have the right setting in place, and you have to be aware that GKE only respects PDB for 1 hour. But if you are using blue green upgrade, we have this feature which is called soak time, and you can have your changes soak there for about 7 days. So that may be a good use case for you. Multiple instances, if it's console zookeeper or any other etcd database that you're running, these are the recommendations. And then if you have a restartable batch jobs, then you need to, you don't have to create the PDBs, and job controller will take care of it. So these are just the recommendations, but it may not directly be, applied to your workload. So choose these settings carefully. Readiness probe, liveness probe, whoever, if you are using GKE at a larger scale, these are the basic settings that we go about. Sorry about that. Readiness, when your service or workload or pods are ready to receive the traffic. And liveness is, as the name says, to make sure that those pods are alive. If not, then restart them. So that you can have like these, both of these settings configured at the same time, but make sure that you have the timing correct, because the readiness is initial delay seconds. It would wait for 15 seconds, and then after trying for 5 seconds, if it does not get any response back, it would get timeout. So these settings, I mean, it's up to us depending upon how much time it's taking for our pod to come up, because we may have some custom script which may require some more time, more than 15 seconds. So yeah, you know do your due diligence, make sure that your application is taking proper time to spin up the pods, and then schedule your readiness probes accordingly. So I'm starting, once my readiness probe is um, you know up and running, or it got the status 200, then only I'm asking my liveness probe to kick in, which is 15 plus 5. After 20 seconds, make sure and check if the pod is up and running, if pod is live. And it would keep like period second 3. It means after every 3 second, it would keep on checking the liveness probe. Now let's talk about the node pool strategy. So we have talked about what are those settings. I mean, there are like release channel, no release channel that GKE takes care for you, um, PDBs, node pools, and stuff like that. But when you create a GKE cluster and when you upgrade it, there are like two settings that you can choose right now. So the default one is surge upgrade. It used to be called the rolling updates. Um, it's a bit less disruptive, but again it's lesser. It's So let me put it this way. So you have surge upgrade, you have blue green upgrades. If you do not want to see any sort of disruption at all, then you should choose the blue green upgrade. And if your application can sustain like couple of minutes or a few percentage of pods to be down at a given point of time, then you can choose the surge upgrade. You also have a way to tune this these updates. So I'll talk about that in coming slides. So just a few recommendation if you want to optimize for speed of upgrades. If your workload is tolerant for disruption, and when I say disruption, it's not like in hours or so, it should be in minutes. um, and graceful termination 60 minutes is acceptable. So you have to decide carefully based on your workload which type of upgrade you want, because both has its pros and cons. Blue green, as so if you're familiar about the concept, it means um, we have a similar infrastructure as blue. Blue means existing one, green means the desired one. So but we have to careful about the number of VMs. So let's say if you have a workload which is using 100 VMs, right? And if you want to use blue green, you need additional 100 VMs for a shorter period of time, until unless your soak time is finished, and then GKE drain those blue node pools. So make sure that you have quota in your projects. You have enough quota to provision 100 VMs, and then after quota, make sure that you have enough capacity. So both of these concepts are different. So once you make sure that you have quota of 100 more VMs, and then you once you have the quota, make sure that you actually have the capacity in those zones or region. So the capacity might be a bit of a risk here, but the upgrade itself is highly available. And as I mentioned here, the workloads are less tolerant of disruption. So since you need like the similar infrastructure for a shorter period of time, it may add to your additional cost. These are few of the settings: maximum surge and maximum unavailable. So this max unavailable is different than the pod disruption budget that we talked about. The wordings are the same, but the concepts are different. So maximum unavailable, minimum unavailable is in terms of your pods rollout, but the PDBs are in terms of your node rollout, because you are upgrading your node pool. So what is max surge? Just want to cover some ground here. So max surge, if you tune your application, let's say if your max surge is 1, so if your application has, let's say, 10 pods, and if you if you provide this setting, let's say max surge equal to 1, the application or the GKE will have one additional pod scheduled, and then maximum unavailable 0. So these are the few settings, the recommended setting that you can do for your application based on how fast you want the upgrade to be completed and how disruptive you want. So if least disruptive, most disruptive, and less disruptive. So based on the criteria, you can choose these settings. Maximum surge is 20, that is the limit. You cannot have more than 20 newer pods at a given point of time. Let's quickly cover the blue green. So as you know, blue green means it's just a workflow, how the blue green actually works. But in a nutshell, the first step is uh, what GKE does. It creates a similar or the same amount of nodes in green pool, that we call it, and then it cordon the blue node pools so that new pods cannot be provisioned on those nodes. and then it drains um, those blue node pools. Once it drains those node pools, scheduler start provisioning those pods to the newer, which is the green node pool, right? And that's when the soak pool duration, that's the concept that we have in blue green, kicks in. So you can have like up to 7 days. You can, your workload can be there in green node pool for up to 7 days. You can do the testing, you can perform all sort of operation there. And after 7 days, blue green will delete the blue pool and make sure your green node pool becomes your current node pool. So simple process, but again a bit costlier than surge upgrade, and you need quota and capacity both. Just a graphical representation, starting with drain, as I mentioned, and then you have your workload migration, and then this is the soaking period. So if during the search upgrade, if you have your pod disruption budget for about an hour, um, and if that does not make sense for you or your use case, then you can choose the blue green upgrades. That would take like about 7 days, and you can make sure that you have enough testing done before you upgrade your node pools from one version to another. I had the demo recorded. I know some of the part did not work during maintenance window, so I had this one recorded that we use internally. So I'll share the link. In the interest of time, we have like 8 minutes left, and I saw that there are few pre-submitted questions. I think we can move on to the question part.
Yep. Thank you so much for that presentation and the demo. And thank you everyone for being on here with us and all of your questions. We've been answering those in the chat, but there are still a couple that we haven't gotten to. So we will start with a few of the pre-submitted questions and then make sure that we're getting to any unanswered in the chat as well. So one of the first questions that we got was, and I'm going to add Gmit to help us answer as well, guidance for keeping track of deprecated features and how we can follow up on them. Some best practices or tips would be great. And if there's an option to make a preliminary check for compatibility of resources with the new version of Kubernetes.
Yep. Thank you, Lauren. So, Chimit, I can take this one. So, out of the box, I'll say there is no such tool, let's say, to compare apple to apple, like from version 1 to version 2. What are those APIs that are going to be deprecated, and what are the dissimilarities between these two versions? But we have insights, we call deprecations, and insights and recommendations available for you. So let me quickly show what I mean by that. So these insights can, sorry about that. I think I lost my presentation.
Yeah, while you're pulling your screen back up, we're dropping a link in the chat where you can go straight to that insights resource.
Yeah. So you see the notifications. So these are the insights. And what we can do is, as you see, I have a new node pool version available. So let's say if you have tens of projects, you can set these insights and deprecations, and then pull all the data to BigQuery, and then you can create your own dashboard, local dashboard, or whatever you choose, to showcase your data on. So we have this insights and deprecation that you can use. It would give you a holistic view of how many APIs are going to be deprecated and in which cluster, so that you can reach out to the cluster admin or cluster owner. Yeah.
Okay, great.
And
our next question is, are there best practices to upgrade or patch GKE clusters without interrupting workloads?
So I think we talked about that. So there are two options. First of all, if it fits your use case, enroll your cluster into the release channel. If not, then you can choose the upgrade strategy, which is blue green. But blue green, as you now know, you have to see some caveats, which is make sure that you have quota and capacity in blue green, and blue green is the least disruptive upgrade strategy.
Makes sense. And going off the topic of blue green, we have a question from the chat.
Mhm.
Is there any way through which we can achieve blue green deployment in autopilot?
I guess I can take this one. So with autopilot, essentially node pool is completely managed, right? So the whole idea of GKE autopilot is that we manage the node pool for you, and you don't need to worry about managing the node pool or upgrading the node pool for that matter, or managing the deployment strategy of the node pool as such. You just deploy your containers, you just deploy your workloads, and then it automatically procures the resources underneath that it needs on basis of the pod manifest or the deployment manifest that has been defined on that. So that being said, like it's automatically managed, like how those node pools are defined, right? If this is in regards to like if you can do blue green upgrade on the node pool of autopilot, then again, like the upgrade of the node pool is handled in an automated manner with autopilot, where Google automatically upgrades the node pool once the control plane has been upgraded, and it follows the surge upgrade strategy underneath. uh,
Yep.
right, so essentially your workloads won't be impacted, since it automatically defines like how to keep them highly available from a node pool perspective. But additionally, you can specify pod disruption budget within your manifests to have maximum uptime as well.
Yep.
Great.
Thanks, you.
Thank you. Okay, we'll go
Um,
to our next one. And I think, yeah, we just have time for a couple more. So if you have any additional questions, feel free to add those into the chat. Anything that scans our workload manifests for deprecated APIs.
so I think we talked about this. So insights and deprecation API recommendations, that's the tool that we have at our disposal currently. So it just scans our clusters for any deprecated APIs, and then let you know in a tabular format or whichever format you want to see your data in. So yeah, we have insights and deprecation recommendations.
Great. If we are running on autopilot cluster, how can we handle upgrades in case there are libraries getting deprecated or there are some changes in the kind like V2 beta to V2?
I think the answer remains the same. We use insights and deprecations. So autopilot cluster, as Jimit mentioned, it's like, let's say, serverless Kubernetes, right? And by default, it has surge upgrade. Blue green cannot be applied, but it's all underneath. You do not have control over how the node pools are upgraded because there are no node pools. So coming back to the deprecated API in autopilot clusters, use the insights and deprecations.
And to add to that, you can first update your manifest to check like to the newer version, that is from, let's say, v2 beta 2 to v2. Apply that, test it in, let's say, a non-prod environment, and then upgrade your control plane to the higher version, so that your workload can get the latest API, and then it is tied back with the control plane as well.
Yep.
Makes sense. All right, we'll take one more. And there were a few other submitted questions that we will have answers to, and we'll provide those in the recap blog post. But we do want to be conscious of your time. So the last one here that we'll cover is there any way to have some node pools with higher availability on a more manual maintenance schedule while still having a cluster enrolled in a release channel?
So if I understand the question correctly, it means you're asking cluster in a release channel. So yeah, so node pools, when you create a cluster, by default is enrolled in auto upgrades, but you can disable the node pool upgrades and upgrade it on your own, terms or time, as and when it suits you. So you do have a option to disable the node pool auto upgrades and upgrade it again as and when you see fit.
All right.
Yeah.
Okay, we got one more from the chat. Is there any tool available to find and update all the deprecated APIs in the namespace or cluster?
So the deprecation insights is based on the cluster level. It's not very granular, so you cannot see it on a namespace basis, but you can definitely look at these APIs on a cluster level. But we are working on it. We are making it more granular in coming months or coming feature. We'll have more granularity when you see these deprecated APIs.
Great.
Yeah.
Okay, well, thank you so much for this presentation and the information and the time you were able to spend with us. Thank you everyone for joining us. The last thing that I will share is that we'd love to hear from you if you enjoyed the session, what you liked, what you'd like to see differently, or if there are any other topics you'd like us to cover or dive deeper into for future sessions. So you can do that with this form dropped into the chat. Just provide your event feedback and any ideas for future topics. That'll take you about 2 minutes. So we'd love to hear from you. And before we close out today, any final thoughts or recommendations from the team?
I just want to add one thing, that we are working on few features internally, which are in pipeline, which are in private preview. So if you have GCP account team, reach out to your TAM or the team. They will walk you through these features. I know GKE upgrade is a cumbersome process, but we are trying to streamline it with these new features. And in a year or so, you will see, the landslide of changes, how we have achieved or reduced these complexities. So, stay put. We are doing everything we can to, reduce the pain.
Awesome.
That's all.
All right. Thank you, everyone. And we hope to see you next time. Really appreciate the time. And I hope you have a good rest of your day, evening, or wherever you are in the world. Thank you.
Thank you, everyone.
Thanks
Take care.
Bye.